फिजिक्स के अंतर्गत यूनिट है एटम एंड न्यूक्ली। नीट यूजी के पेपर में इससे एक क्वेश्चन आता है और यह क्वेश्चन थ्योरेटिकल भी हो सकता है और न्यूमेरिकल भी हो सकता है। 2021 में नीट यूजी पेपर में फिजिक्स में एक क्वेश्चन आया था। अ न्यूक्लियस इज विद मास नंबर 240 ब्रेक्स into two fragments each of mass number 120. The binding energy per nucleon of unfragmented nuclei is 7.6 megawatt, while that of fragments is 8.5 megawatt. The total gain in the binding energy in the process is, there are four options: 216 megawatt, 0.9 megawatt, 9.4 megawatt, 804 megawatt. We will solve this question. Mass number of reactants is 240. Binding energy per nucleon is 7.6 megawatt. Mass number of products is 120. Binding energy per nucleon of product is 8.5 megawatt. Total gain in binding energy is equal to binding energy of product minus binding energy of reactants. That will be equal to 120 plus 120 into 8.5 minus 240 into 7.6. That is very simple. 120 is 240 into 8.5, that is 2040, and 240 minus 240 into 76, that is equal to 1824. Now answer will be 216 megawatt. In NEET-UG 2020 code E1, there was a question: for which of the following Bohr model is not valid? First option was hydrogen, second is singly ionized helium atom, third deuteron atom, fourth singly ionized neon atom. Answer is fourth option is correct. Explanation is such that Bohr model is only valid for simple electron species. Singly ionized neon atom has more than one electron in orbit. Hence, Bohr model is not valid for ionized neon atom. In 2019, there was a question: the total energy of an electron in an atom in an orbit is minus 3.4 electron volt. Its kinetic and potential energies are respectively. First option was minus 3.4 electron volt, minus 3.4 electron volt. Second option minus 3.4 electron volt, minus 6.8 electron volt. Third option 3.4 electron volt, minus 6.4 electron volt. Fourth option 3.4 electron volt and 3.4 electron volt. क्वेश्चन को समझ लें. द टोटल एनर्जी ऑफ एन इलेक्ट्रॉन इन एन एटम in an orbit is minus 3.4 electron volts. Its kinetic and potential energies are respectively. We have to calculate kinetic and potential energies. Question is very simple. In Bohr model of hydrogen atom, kinetic energy is modulus of total energy, that is modulus of U upon 2. So kinetic energy is plus 3.4 electron volt and potential energy is minus 6.8 electron volt. So option 3 is correct. NEET-UG 2000, there was a question for radioactive material half-life is 10 minutes if initially there are 600 number of nuclei. The time taken in minutes for the disintegration of 450 nuclei is, first option was 20 minutes, second 15 minutes, third 30 minutes, and fourth 10 minutes. This was very simple question, and right option was first 20 minutes. This can be solved by two methods. First is shortcut method. The half-life time is half-life time is 10 minutes. There are initially 600 nuclei. 300 nuclei will disintegrate in 10 minutes. After that, 150 nuclei will disintegrate in 10 minutes. In 20 minutes, there will be disintegration of 450 nuclei. That is the shortcut method. But in the mathematical, the process is n naught is 600, or n is equal to 600 minus 450. That is 150. T half is 10 minutes. Now we will use the formula n is equal to n naught half raised to the power n, and 150 upon 60 is equal to half raised to the power n, and n is equal to 2. Now we will use the formula T is equal to n into T half. T half is half-life time. T is the total time of disintegration. That is T is equal to 2 into 10 is equal to 20 minutes.